All right, we'll go ahead and get started. So good morning, good afternoon, and good evening to all who are able to join today's webinar covering our new exciting product, the 78 series full bore from Trillium Flow Technologies. So we'll begin the webinar by introducing our speakers and Trillium Flow Technologies as a company. We'll briefly cover our pump and valve brands along with our strategically located manufacturing and service centers. We'll touch on the key differences between a spring-loaded valve and a pilot-operated pressure relief valve, and then we'll discuss the key features and benefits to our new 78 full-bore pressure relief valve. My name is James Keating, and I've been with Trillium Flow Technologies for almost a year now as an analyst for the Saracen line of pressure relief valve.
My name is Sébastien Vermeulen. I hold a master's degree in fine element analysis and joined the PRV industry in 2009. I became familiar with the ASME code during 5 years in the engineering department before joining Trillium, its product team, and being focused on the Saracen pressure relief valve line.
So a quick overview of Trillium Flow Technologies brand portfolio. So Trillium designs and manufactures mission-critical pumps and valves and provides aftermarket spare parts and service to the global power generation industry, industrials, water and wastewater, and oil and gas industries. So we represent 17 long-standing trusted brands, many of which date back over 165 years. And many of these brands are recognized globally. And so for some insight on Saracen, we recently celebrated our 170th year anniversary back in 2018. So we serve our customers through these 11 manufacturing sites and 4 service centers located strategically throughout the United States, the United Kingdom, France, Italy, Netherlands, South Korea, China, India, with 2,000 employees globally. So Trillium Flow Technologies is a long heritage of innovation dating back almost 200 years. We're continually adding new products and services to ultimately serve our customers and make their processes more efficient and ultimately more productive. So to give a little bit more insight into the origins of Saracen, so the Saracen brand was born in 1848 and began as a forging mill that quickly grew and became a workshop for general mechanics. And years later, in 1983, Saracen was sold to the US company Anderson Greenwood, who were the leading manufacturer of pilot-operated pressure relief valves at that time. And so Saracen at this point became Agco Saracen and manufactured pilot-operated pressure relief valves, particularly for the French market. And so Trillium still shares the same pilot-operated relief valve technology with our main competitor today, which is Anderson Greenwood, owned by Emerson. And so a few years after that, in 1986, Anderson Greenwood was purchased by Keystone International, another American organization. And Saracen the following year became Keystone France. But just a couple years after that, Keystone ceased manufacturing of Saracen products. But in that same year, Sabine Holdings, and Sabine today is our brand of pressure relief valves covering the nuclear industry and nuclear applications. And so Sabine bought Saracen, and that later became Saracen Holdings. And so Trillium was finally established in 2019, and we understand this name might not ring a bell, but you might be more familiar with Weir. So we were part of the Weir Group from 1998 till 2018, so for 20 years, until Trillium Flow Technologies was eventually established in 2019. So now we'll touch on the differences between a pilot-operated pressure relief valve and a spring-loaded valve, and ultimately why we decided to extend our product portfolio to the 78 series full bore. Why should I pick a pilot-operated pressure relief valve? So regardless of whether it's a spring-loaded valve or a pilot-operated relief valve, a pressure relief valve is self-actuated and should be able to operate at any time, opening at the right set pressure and discharging at its certified capacity. So there are many benefits to selecting a pilot-operated relief valve, but in the interest of time, we'll just focus on 3 of the key benefits here. The first being performance in terms of high back pressure. So back pressure has a direct negative impact on both of the performance characteristics that we just mentioned, so the set point and capacity. And so that can potentially reduce the valve's lift. And the situation can potentially worsen when the back pressure is variable, because the set point at that point just becomes simply unpredictable. So in the case of high back pressure occurring, a pilot operated valve will be your best solution, since that main valve piston is going to be protected by the guide and fully balanced, keeping your process on the safe side and mitigating process risk. The second is the pressure and size capability. So when both capacity and set pressure exceed the limits of a spring-loaded valve, a pilot-operated valve is going to make all the difference. So there's really two reasons for this. So the higher the pressure, the larger the spring required for a spring-loaded valve. And that spring has to fit into the bonnet volume chamber, which already has limited space to begin with, and that spring cannot increase infinitely. And second, the larger the orifice, the lower the pressure that's selected. So a pilot-operated valve is not going to be limited by a spring, and its body pressure ratings and its wall thickness are especially enhanced to be able to accept higher pressure for similar sizes. So in this case, a pilot-operated relief valve is going to offer you the best alternative for ultimately reaching that highest pressure and also that highest capacity. And then the final reason we'll touch on here is the seat tightness. So thanks to a larger percent seal dome relative to the inlet seat, the pilot operated relief valve remains perfectly tight up to 98% of the set point. And that's going to be 8% more than any basic spring-loaded type that has a metal seat. And so the pilot operated valve has many other different advantages and also additional components and options that can be added. And we'll introduce those later on within the presentation. So before we dive deeper into the 78 full bore, its case study and principles of operation, I just want to give a quick overview of what the customer benefits are and what's gained from selecting this product. So the main benefits of selecting the 78 full bore is that it provides that additional capacity while having a smaller inlet size and less weight compared to other API orifices. And so that extra capacity is going to drive down the quantity of valves required by the end user, and it's going to drive down your maintenance costs. And so the enhanced seat tightness is also this model has enhanced seat tightness, enabling the seat to remain perfectly tight up to 98% of the set point, as I mentioned. And this is going to allow for minimal leakage and minimal reduction in GHG emissions, and ultimately more throughput for your process. And finally, and maybe most importantly for customers, is that the 78 full bore dimensions match those of major valve brands used around the world. So now we'll move on to a more detailed overview of our new 78 full bore pressure relief valve, and I'll hand it off to Sebastian Vermeulen to break down the features and benefits of this product.
Thanks, James. So as a start, let's analyze first the market and the reason why 78 full bore has been developed. So in the oil and gas industry, the service condition continue to increase and the operating pressure, what we call the money maker, has never been so close to the equipment design pressure, what we call the maximum available working pressure, to maximize the process efficiency. So in this environment, pilot operated pressure valve offers the best alternative solution, withstanding the highest operating pressure and relieving the highest capacity. This new valve has been designed to meet customer specific needs and or a specific line in the process where high capacity are required. For sure, 78 full bore can not only be the main solution and the unique solution in your process, but on some specific line where you need extra capacity, where finally you reach the limits of API. On that case, this valve can be a good alternative solution that will lower your total cost of ownership. So again, during our customer visits that include a refinery, LNG plant, we perform some voice of customer. And during this visit, it has been identified API standard 526 standard pilot operated valve can be part of a multiple selection. So it means on the same pipeline, you have some valve installed in parallel and that are staggered. And on that case, it could be replaced by this new design. So basically, we address the LNG, the FPSO at any level, upstream, midstream, downstream too, especially upstream. So what is finally the 78 full bore? It's not completely a new product. 78 full bore has been designed as an extension of the 78 series. 78 series, which is the main API standard 526 pilot operated valve. The main difference with the 78 full bore is the center two phase dimension cannot meet NPI. Indeed, and again, the API has its own limitation. One example is, for example, the full nozzle, sorry. Full nozzle, if you take a look on the API, full nozzle is introduced with many benefits. Full nozzle are integrated weighted components, which offers the advantage of removal for easy maintenance and replacement. And it's also offer an additional benefits. With, what is, you can easily perform material upgrade separately. So nozzle and disc are the only weighted part, and you can upgrade with material, keeping your pressure containing component like body as a basic carbon steel. So that will allow you to do some cost saving. Unfortunately, if you take a look on API standard 526, this design is only suggested for spring-loaded, not pilots. That's why we need to develop complementary custom-made solution. It's quite similar here. A customer needs and draw our attention on a new solution that provides extra capacity while having a smaller inlet size and less waste compared to other API refis. So the main valve, that we designed a new main valve. So the main valve is completely new. However, it is combined with try and tested pilot technology. So as you can see in this graphic, we have two kinds of pilot, either pop or modulating action pilot. So here you have the pop action pilot, and here you have the modulating action pilot. All are non-flowing pilots, which means there is no pilot flow when it is in a stable position. Only fluid, which is localized within the dome, is discharged when the pilot becomes unbalanced. It offers a key benefit that offers better main valve stability, better performance, especially on dirty service. We will talk a few later at the end of the presentation regarding the different kind of accessory, backflow preventer, remote sensing line, field test. So that's the reason we move fastly on this technical feature. So what is the takeaway in this slide? The takeaway here is all valves offer the same certified capacity, offer exactly the same performance. Finally, the section area here is the same here, is the same here. So the selection on one valve instead of another will really depend on the customer and the market needs. So for those of you who are attending this presentation but are not familiar with our brand, let me give you some color of this product. Now, historically, we have two types of pilot operated valve. On the left hand, the 78 series, it's what we call the semi-nozzle because the nozzle is integrated into the body. So the POPRV, the 78 series, represents a perfect product that meets 100% of the requirement of the API standard 526 with standardized dimension and the possibility to interchange with another brand. In a nutshell, 78 series pilot operated valve meets the requirement of EPC contractor who want to stay as close as possible to the API because API is a guideline. They are very comfortable with API. It's good to, it's okay for us. And on that case, they don't accept any deviation. On the right hand, we have the 76 full nozzle. It is exactly like a spring-loaded type. So you screw the nozzle from the bottom. The weighted parts are limited, the body is protected. So this nozzle, as previously mentioned, offers the advantage of limited parts and therefore is preferred for corrosive application, easy of maintenance. Based on our spring-loaded body casting design, it's allow easy process upgrade, solves spring-loaded shattering issue that customer might have. So basically, if you want to perform an upgrade from spring to pilot without having to change your piping connection, you need to go with such kind of solution. In a nutshell, 76 series meets the requirement of EPC contractor who understand the benefit of the full bore and understand also API structure. The fact spring-loaded and pilot operated table has been split in this standard. You have 14 tables for spring, 14 tables for pilot, and accept this minor deviation adopting this pilot technology. So, and in the middle, we have our new 78 full bore series. As you can see, the design is very, very compact. It's unmatched section area for such kind of volume. In that case, 78 full bore directly address end user who are looking for a solution that will reduce their operational cost. So let's go more in detail regarding the principle of operation of this product. So 78 full bore is available in two versions, either single outlet or dual outlet. There is 7 sizes for the single outlet, 6 sizes for the dual outlet. We have 2 certificates for this product for gas and liquid application, but it's one single certificate, whatever the product configuration. It can be single or dual outlet. At the end, it's one single certification. That's the reason we mainly qualified the section area, and in total, we propose 9 section area. Some of them overlap between the single and the dual outlet. Each configuration, of course, has its own advantage. On one hand, the reaction force you will have on the single outlet result in support that will involve additional cost. On the other hand, it is true that the dual outlet, on dual outlet, you don't need for any piping support, but that will impose a specific piping connection. We offer here the customer the choice to define the best solution for his process. But for sure, it needs to define at the beginning. So it's mainly for project OE markets, because from the beginning, you need to identify what kind of piping you need to put in place to adapt such kind of dual outlet design. Our experience in manufacturing pilot-operated valve, average 1,000 per year, leads us to reduce the volume of the dome. In the piston is localized on the dome, and the dome is this section area here. So here you have a standard dome section area, what you will find on the 78 series, and we tend to reduce this volume. In order to reduce first, because based on our experience on ASME1, so ASME1 is for steam industry, but the criteria for ASME1 are very, very stringent, and the blowdown for such kind of valve should be between 2 and 4%, when in ASME8, the blowdown is more close to 7%. So to guarantee to increase the blowdown performance, we need to increase the valve response time. And to reduce this valve response time, we need to reduce the volume. The higher volume, the lower response time, because you need to pressurize, depressurize the dome. It's operational time that's reduced the valve response time. So our experience in this domain leads us to reduce this volume, to reduce the heat exchange, but also to optimize the main valve control. So there is different kind of solution. We can either adapt an insert like here, or we can directly design a casted inless casted piston, what we did here. So on that case, reducing the machining for spring location, so either using inless casting or insert, that allows us to offer a fair price for our customer, because the main specification for such kind of valve has been to be aggressive in terms of price. Pursuing a cost-effective solution approach, but also optimizing our own stock management for spare parts, the valve has a unique trim per size. It's a real benefit. Don't get me wrong. We have 9 size. So we have 9 trim. But the core DNA of the product has been really to reduce the cost, and it is interesting to keep the same trim, whatever the pressure class. That's permit to limit spare units on shelf internally, but also externally for our distribution networks. We keep it simple, minimizing the trim you need to all in spares. That's again lower your total cost of ownership. For those who has been really who are listening to me from the beginning, we said we address the LNG market. And for those who attend the webinar we did 2 weeks ago about the LNG process, You know now on the LNG process, you have one specific part when you move in cryogenic condition to make to to convert a gas into a liquid at the minus 196 degrees Celsius. We said the trim is unique. That's true regarding the pressure class. That's also true regarding the service condition. Piston, for example, has been especially adapted to accommodate either a O-ring seat as a standard or an energized PTFE seal for cryogenic condition. It's also true for any part. So here the piston design is unchanged and we can put in place either O-ring or energized seal. Here also, on the bushing here as well, there is some specific location when we can adapt the gasket to make the valve capable to operate in cryogenic condition. So whether it is about a retrofit or inventory stock management and or easy of execution in the supply of spare parts, the product has been designed to meet customer requirements throughout the complete valve life cycle. Much like a North Star, the product principle has been to reduce the spare you need to carry and lower the TCO. More important, the seat, because the seat is especially discussed when we have some technical requests from customer. So in cryogenic condition, let's be clear, our own Sarrazin own recommendation will be always in favor of a metal seat. However, we know that sometimes it's necessary to meet specific customer requirements, and the soft seat is one of them. So let's give me the opportunity to educate a little bit during this presentation. Customer would know how pilot-operated valve works, will recognize that the soft seat is useless or is only useful for spring-loaded valve. On spring-loaded, you have the pressure, you have the spring. When the pressure increases, the disc starts to be balanced and the valve starts to leak. On pilot-operated valve, the highest pressure, the highest tightness, because you pressurize the dome section area. Forget the spring, you just pressurize the dome section area, and that increases your seat tightness. So it doesn't make sense to have a gasket, because on that case, gasket doesn't help to reach a higher tightness. Furthermore, a damaged soft seat will tend to leak more than a metal seat. And for those who are familiar, with the failure mode analysis, you know the higher numbers of parts you need to consider, the higher risk of failure. So it's an advantage to reduce, to limit the number of parts and to not adopt any soft seats. But again, Trillium always take a leading role and notify the customer of any non-conformity, but we also try to meet all requirements by providing a soft seat when we cannot deviate and that is specially required on any specification. So we can propose both, either metal or soft seat, whatever. We work with gasket manufacturer. I can provide such kind of technology if needed. So we review some principle of operations and technical characteristic. Let's move on now on the case study to illustrate the valve performance compared to the 78 series. So let's try to be here a little bit more factual, taking into account few metrics that will allow you to illustrate how much better this valve performs than its predecessor. If we consider only the piping inlet size, what we are not supposed to do, to be honest, don't overlook, a safety valve is first designed as a unique solution for a specific overpressure scenario. So normally we don't care about the inlet outlet. You have overpressure scenario, we perform sizing to offer the appropriate set pressure, but also the relieving capacity to protect your vessel, your pressurized vessel against overpressure. So that's normally the philosophy. But just for the demonstration during this webinar, we just compare not apple to apple, because normally we need to compare the section area, but the inlet at similar inlet flange, how bigger, what's the section area difference? So immediately here in this exercise, we just on phases, the flow area can be up to 3 times larger. If you take a look on the key orifice 3x4 offer a section area whose section is 13 to 2.09 inch square. And a similar full bore, it's a 674 inch square, so it's 3 times larger, which is especially what is a big it's what is significant. The section area is so important on full bore. We need to pay attention to the pipe wall thickness, what we call the schedule for the valve sizing. Because yes, of course, we don't have to forget the rule of installation. The valve has to be installed vertically, but also we need to take care there is no reduction on the valve to guarantee the valve is able to relieve its relieving is required relieving capacity. So the full capacity. Otherwise, the valve performance will be affected, of course. So in a more practical way, let's look at a customer request riverside. Here we have a basic input data, so set pressure, relieving temperature, required capacity. The fluid is steam to make it more simple. And we have a comparison between, on one hand, the standard 78 series, on the other hand, the full bore. On each scenario, you can see here you have a multiple selection valve that can be simplified by one single valve. So in the API, the API show its limitation. Why we use 2-valve or 4-valve orifice T? It's because in the API, you only have 14 size from orifice D to orifice T. Once the maximum permissible orifice is reached, it is necessary to switch to a multiple selection. So it's an issue. The full bore appear at this moment as a valuable proposition, as the reduction in the unit is drastic, up to 4 times less, as you can see for the PSV1 and the PSP4 when we reach the highest size, and that can be replaced by one single full bore. This might seem a less important criteria, but weight is also a consideration, especially on offshore platform, what we call FPSO, FLNG. Because the safety valve is first designed as a unique solution for a specific overpressure scenario, we are now considering equivalent section area instead of pipe or a valve inlet frame size. So regardless the technology, the pilot operated is mostly a preferred solution for such kind of market, FPSO, due to the fact the weight is reduced and the fact you offer better capacity size ratio. But full bore, again, raise the bar even higher. Its compact design allows for a reduction of up to 4 times for almost the same cross section, as you can see here. So 200 kilogram reduced to 57 kilogram for the equivalent of orifice P, for example. The weight is reduced, the volume is also reduced. The Zirchow performance required a reduction in the volume. If it's true for smartphone, it is also true for FPSO, where space on board is a criteria just like weight. Still comparing equivalent section area, the volume saving is also consistent, as you can see here. Finally, no matter how good a solution is, it will only be retained if it fits in the market price level. In a world in full energy transition, the cost impact is at the heart of the debate. Here, the price again is a consequence, it's not magic. It's a consequence of all the technical features we presented before, the reduction of size, the reduction of weight, the reduction of volume. So that has a direct impact on the valve price at the end. We will explain again and again, but we need to compare. We cannot compare 78 series and 78 full bore of similar size, but rather to compare valve with a similar performance and therefore similar flow rate. Based on that, on this comparison, on that case, the cost impact is significant. So here is just an equivalent, just a comparison. We just consider a valve inlet pressure, inlet class 300 for carbon steel, metal to metal seat configuration. And it is mainly based on the body main valve comparison because as we explained, we use the same pilot technology, whatever the main valve type. So let's move on now on some additional information, some option, some technical feature we put in place, but could look like, let's go more in detail on that case. So it might seem pointless, but the bracket has been directly incorporated on the 78 full bore. It's just to show how well thought out the product is. So based on our experience and always with a view to reducing the part that can be a potential root cause of failure, like the bolting, for example, we have thought to integrate the bracket into the design of the valve. Here, the pop action pilot is directly connected to the main valve. It's directly integrated in the main valve. The bracket is a cast design integrated in the main valve. On the modulating pilot, the bracket becomes unique. It's only one part. There is no, how can I say, the bracket is not bent like here. It is just a single plate that will better resist seismic force, although it is true that this type of criteria, the seismic condition, is mainly considered on a nuclear requirement rather than the oil and gas. But as mentioned by James during this presentation, Sarrazin and Sebim are two unique companies with one single headquarter based in France. Sarrazin is the oil and gas and power focus, power for conventional power plants, and Sebim is more focused on power for nuclear activity. We share some technology. We use a specific pilot for a nuclear segment. It's not the same price level because it's not the same price as the same study. Seismic condition, irradiation, such kind of thing is part of the nuclear business. And so that's the reason we are a little bit concerned, and probably that will drive the engineering decision to optimize the brackets. So let's move on now some of option like the field test. We supply standard option, so field test connection is one of them. Everyone will recognize one of the major advantages of the pilot operated valve is the capability to propose efficient inline maintenance. Any safety valve should be inspected every 1 year. However, the lift assistance device that you will find on spring loaded is not really convenient. It's not really efficient for two reasons. First, due to the operational time to install and install the device in relation to the quantity of valve installed, because on oil and gas, you can have thousands on valve. It's not like power section. And also the relative accuracy you may have if the operator is not skilled enough, not to mention the risk of damaging the seat and therefore causing a premature leak. So from a cost analysis perspective, the field test connection is one accessory that significantly reduces maintenance costs. Unlike the spring-loaded type, it's allow an easy valve stroking with an auxiliary device. It can be either air or nitrogen butter. And without disassembling the valve, it's about a free two-way valve that will snap the pilot in open position and makes the valve open regardless the system pressure. So it's really convenient, it's really easy to use, it will also lower your TCO. So for all these reasons, definitely a pilot makes a difference, and such kind of option is really, really convenient to use and should be preferred when you adopt a pilot technology. As the backflow preventor is another one, which is very famous. As the name suggests, and as explained already by James, the backflow preventor accessory prevents the main valve from lifting early, eliminating the possibility to contaminate reverse flow. It's also a big advantage, yes. The fact, sometimes, because most of valves are connected directly to the flare, if the fluid penetrates into your process, you have a contaminated process. So backflow preventer prevents such kind of risk of contaminated reverse flow. It prevents the 78 full bore pilot operated valve to turn into its vacuum position when it is not required. Again, like field test, it's a free two-way valve, which always guarantees that the higher pressure loads the dome and ensuring the valve will not open before the set point. Another one, which is very famous when you need, and most of the time, that's also the main reason why you need to adopt a pilot instead of spring-loaded. It's a remote sensing line. So as sometimes some precaution needs to be taken to control the shattering risk when you install a valve into your process. If API already address some PRV stability issue through the 3% pressure drop rules in 1963. So it's true, sometimes it can be an issue. It can cause by either system instability or local pressure loss due to a flow path variation. The pilot operated pressure valve offers the benefit of connecting the pilot to the pressure vessel through the remote sensing line. So it's a static line. Here you have the red line that will be directly connected to your pressure vessel. And unless a net upward force is generated by the pressure vessel to open the main valve, the pilot will never actuate prematurely, preventing system-wide cycling and shattering, plus unexpected overhaul on the downstream equipment. So this is again a non-negligible option in as much as unresolved shattering can damage the wall installation. So again, the takeaway is such kind of solution will keep a stable open position, prevent shattering issue, and increase the system stability. So thanks for, I hand over now to James for the final part of this webinar, some conclusion before moving on the Q&A session.
All right, thank you very much, Sebastian. Before I head into our Q&A, I just wanted to cover a couple more slides. So displayed here is our model range for the 78 series full bore, including the single and dual outlet models. So I know there's a lot of information here on this slide, but we're happy to provide these details upon contact with our sales team. And there will also be a QR code available on the final slide too, and more information about this product can also be shown there as well. And we want to encapsulate the value proposition that this product is ultimately going to bring to customers. And so we'll start with customer needs that we're addressing with this. The first is overall performance. And this primarily speaks to the fact that the valve is able to provide that extra capacity while having a smaller inlet size and less weight compared to other API orifices. So while the valve exceeds API criteria, it still matches the interface dimensions of all of our major competitors. And since the 78 full bore is a pilot operated relief valve, that valve efficiency is ensured, particularly the zero leakage requirement, which is going to help mitigate safety and emission reduction challenges going forward. If you look at the bottom, the key features and benefits include that maximum permissible nozzle size that will ultimately allow that valve to reach its highest valve capacity, provided that the piping inside the diameter is equal or higher than the valve section area. And so this will drive a reduction in the quantity of valves required. It's going to reduce that required size and ultimately drive down those maintenance costs and reduce maintenance time. And also in terms of maintenance, the 78 full bore has that unique trim that we discussed and can accept different gasket types. So either a standard O-ring or a PFT for cryogenic applications. And this main valve design has been optimized to reduce dome volume and improve valve response time. And so the value that's unlocked through selecting this product can be shown in the middle. One, the reduction of valve quantity having an impact on your bottom line and driving down operational costs, driving down maintenance costs. The smaller sizes required also reduce the maintenance and subsequently reduce that downtime. And the benefit of the pilot operated relief valve makes it possible to achieve the highest possible operating conditions while reducing process loss and ultimately increasing throughput and getting more product out of your process. And so that is going to conclude our presentation, and we'll now move on to our Q&A. And again, there's a QR code here. So if you want to access any additional information right now, please feel free to scan that QR code.
So we have a first question. Is there a solution to use this pilot-operated valve in oil production water application that contains suspended particle that can clog the pilot? Good question, to be honest. On PLV industry, what you need to understand is whatever the valve technology, and it can be spring-loaded or pilot-operated valve, it's not a pump or you need to understand the tightness is mainly ensured by metal-to-metal seats. So you have the nozzle, you have the disc. It's true for a spring-loaded or pilot-operated valve. And when you use the valve is very, very efficient, provided it is properly sized, installed, operate, and maintain. But there is operation. And you mentioned a point regarding the operation, the suspended particle. We certified the valve for sorry, for a different kind of media. It can be gas, water, steam, but we cannot handle any particle. Particle, it's a very, very general term. And there is no tolerance. I cannot say, okay, the particle is limited to 5 micron or such kind of thing. It could be accepted. No, the answer is very clear. It is no. It's even worse when we, for example, when we perform extraction for FPSO. In the extraction, you have a lot of sand, and sand is a very small particle, but it's very, very, very corrosive. The valve is completely destroyed. So it just to illustrate the fact for whatever the technology, there is no safety valve that can work. We cannot guarantee the seat tightness if the valve operate with a media that contains some particle. I discussed during my webinar regarding some how we can educate people and was the reason why the soft seat is not preferred. And the soft seat, for example, is another example. But when you have some particle, and if you have the soft seat, it's even worse because the particle will penetrate into the soft seat and will completely destroy the soft seat. So there is again no solution. It can be you can use metal or soft seat. We can probably maybe apply stellite, but at the end it will be eroded. So no. And that's also the reason why any pilot is not preferred when you need to have to handle some particle. We can apply some filter, but the risk is at the end the filter is completely clogged by the suspending particle. So most of time when you have some source, not source service, but some particle, on that case, a spring-loaded will be preferred. Another question. I assume the same will apply to the fluid that can form a solid phase. Yes, we don't handle a solid phase. We handle media, so gas, water, and steam application. Did you approve high temperature limit for steam application up to 450 degrees? So yes, it's not firstly designed for that, but yes, we can. We have some option to protect the pilot operated valve against such kind of temperature. This valve, as I explained in the scenario, if you follow all the presentation, we take different kind of scenario. We highlight the valve is able to operate in cryogenic condition, but also on the steam application. So it's a big gap. On that case, we also put in place different kind of option, what we call the cooling coil. So just to educate and to make the difference between, because there is two different cooling coil. One cooling coil will have a horizontal axis. On that case, the reason is on the cooling coil, we want to create some water plug. So such kind of cooling coil will work on steam application. And for cryogenic service, on that case, the axis of the cooling coil is vertical. The cooling coil is like this. And it's allowed to avoid any water retention and to avoid also any ice plug, because if you create an ice plug, it doesn't work so well. So cooling coil is the level 1 if you want to protect your process against high temperature, high or extreme temperature, high or very cold temperature. And sometimes you can also use some buffer tank, what we do with the 76 economizer, the ASME1 valve we put on the economizer line. And in that case, we perform some upgrade. We upgrade the cooling coil and we replace it by a buffer tank. So yeah, the other question is just to present and to share the presentation. Well, just for your information, at the end, this webinar is recorded, and if you take a look on the QR code you have here, if you scan it, you will have a direct access on our YouTube page, and you will have an access to all webinar. That's probably the most convenient way to review and review all technical detail we present during this webinar. Or if you really need the presentation, it can be shared. It's not a big issue. Any question, don't hesitate to contact us. We have a global email address, and on that case, I can reply your questions separately. Thanks for your attention. James, anything you had from your hand?
No, that's it. Again, if anyone has any questions, don't hesitate to reach out. We want to thank you everyone for joining. We hope this was insightful. And again, if you want to learn more about this product, please feel free to scan that QR code or reach out to one of us or our sales team.
Thank you.
Thank you.